This next section is on partial derivatives. So let's talk about the concept and the notation. So first off, partial derivatives show the rate of change of the function value when one of the input variables increases by 1 and the other variables remain constant. So we may have a notation, let's say if we're given f of x, y, and z, there are a few ways that we can denote a partial derivative. So if we have the partial derivative with respect to x, we might have f with a little subscript of x. They might use the entire notation with a subscript of x, y, and z. They may say a partial derivative of f with respect to x, or partial derivative of f of x, y, and z with respect to x. One thing to note here is they are using what I would call just a curly D to denote partial derivatives. Now, when we're taking the partial derivative, remember that the derivative of a constant is 0. Any variable we are not differentiating with respect to, we treat as a constant. You might want to highlight this. This is a key part that tends to mess people up. Any variable we are not differentiating with respect to, we treat as a constant. So that means their derivative is going to be 0. So in example A, we're dealing with a polynomial. We have the function f of x, y, and z that equals 2x cubed minus 5y squared plus 8z. In part A, the only derivative we're looking for is going to be with respect to y. That means that we would treat this x here as a constant, so that derivative would be 0. This is the y term, so we would take the derivative of that, which would give us a negative 10y to the first. And again, we would look at z as a constant, and that derivative would also be 0. With part B, again, we're looking for the partial derivative, but with respect to z. So our first term with the x, that derivative would be 0. Second term with the y would be 0, but the third term derivative would just be 8 with respect to z. And in part C, it's asking for the partial derivative of that function with respect to x. The only term that has x in it is our first term, and that derivative would be 6x squared. Now in part B, we have multiple variables per term. So we're considering f of just xy, but it equals 3x squared minus 5x squared y cubed plus 2y cubed. So we want to find the following. In the first one, it's the derivative with respect to x. Well, our first term is just 3x squared, so that derivative would be 6x. In the second term, it is the x that we will be taking the derivative of, which will give us a negative 10x. That y is a constant. So remember, the constants come along for the ride. Let's say if it is the coefficient, right? The coefficient would stay. We just would not use the product rule here because when we take the derivative of the y, it would give us a 0. And again, our last term only has a y, so its derivative would also be 0. Part B, we're going to do it again only with respect to y. So our first term, that derivative would be 0. If we take the derivative of our second term with respect to y, we would get a negative 15. The x doesn't change, and y squared by subtracting that 1. And the last term would give us a plus 6y squared.